In this illustration, we will find the change in hybridization of the atoms in the following cases. Let us start with the first case. The first case, we can see that the benzene is converted into a benzene carbocation. So, if we find the original hybridization of this atom, we find it to be sp2 because it has 3 sigma bonds and 1 pi bond. Therefore, the hybridization is sp2. In the second case, we find out that there are 2 sigma bonds and 1 pi bond. The hybridization expected is sp, but we clearly know that for ringed cases, sp hybridization is not possible for a 6-member ring. This implies that this positive charge is not in its pure p orbital state, rather it is in an hybridized orbital. Therefore, we will consider this positive charge as an hybridized orbital, making 3 orbitals present for hybridization. Therefore, this is again an sp2 hybridized atom. So therefore, there is no change in hybridization. In general, the positive carbocation is in a pure p orbital which does not take place in hybridization. But since it is a not possible case to have a linear or sp hybridized situation inside a 6-member ring, we have to consider this p orbital or this positive charge to be an hybridized one rather than a pure one. Therefore, this is an sp2 hybridized carbon atom. Let us talk about the second case. The second case, very clearly we can see that originally every atom is sp3 hybridized because of 4 sigma bonds. But now individually they are all formed into different categories. Let us analyze individually. Talking about A. For A, we can see that it has converted into a carbocation. We can write it down also, carbocation. Therefore, we can see that there are 3 sigma bonds and this positive charge in its pure p orbital state. This positive charge is a vacant p orbital. Therefore, it is in its pure state. So there becomes 3 sigma bonds, making the hybridization to be sp2. Therefore, in the case A, the hybridization changes from sp3 to sp2. Talking about case B is the case of a triplet carbene. Triplet carbene, we can analyze it very carefully that the molecular structure is somewhat like this. Triplet carbene, these are 2 single electrons present in different orbitals. These 2 single electrons will generally not participate in the hybridization unless this carbon atom has a very high positive charge induced in it. In general cases, we don't assume that there is a positive charge induced. Therefore, these 2 electrons will not individually participate into the hybridization, making 2 sigma bonds available for hybridization. Therefore, the hybridization of this carbon atom will be sp. For B, the answer will be sp3 to sp. C case is a case of singlet carbene. Drawing the structure of singlet carbene, we can see that the structure is somewhat as follows. It has 1 lone pair and 1 vacant p orbital. Singlet carbene, we can clearly see that there are 2 sigma bonds and 1 lone pair and 1 vacant p orbital, that is in a pure p state. So there are 2 sigma and 1 lone pair, making the hybridization of this carbene to be sp2. Therefore, in the case C, the hybridization changes from sp3 to sp2. Lastly, talking about the D case is a negative charge. It's a anion or a carbonium, whatever you can say it. These 2, there are 3 sigma bonds and 1 lone pair. Negative charge can also behave like a lone pair. It is a lone pair indeed. So there are 3 sigma bonds and a lone pair, making the hybridization to be sp3. Therefore, in D case, there is no change. The sp3 remains sp3. Talking about the third variety is a form of a reaction. This is a case of normal Beckmann reaction or a rearrangement. and we need to find out the change in hybridization of the atoms. Now clearly this segment remains unchanged, therefore the hybridization of these carbons remain the same. Talking about this carbon was originally having 3 sigma bonds and 1 pi bond. Therefore, the hybridization was sp2, and in the final case, this carbon atom is here, and again it has the hybridization as sp2 only. There is no change in hybridization. Talking about this carbon, this was originally sp3. Here also it is again originally sp3. Now let us talk about this oxime segment, or this nitrogen and oxygen segment. This nitrogen was originally having 2 sigma bonds and 1 lone pair. The hybridization becomes sp2, and in this case the hybridization is, it has 3 sigma bonds and 1 lone pair, but the lone pair is taking part in resonance, therefore this is still having 3 sigma bonds and 0 lone pairs, therefore it is also sp2. There is no change in nitrogen's hybridization. Also talking about oxygen's hybridization, this oxygen contains 2 sigma bonds, 2 lone pairs, but one of the lone pairs is participating in hybridization in resonance, therefore this will not be considered in hybridization, therefore this oxygen is also having sp2 hybridization. Similarly, for this oxygen it has 1 sigma bond and 2 lone pairs, none of them is participating in hybridization, therefore this is also an sp2 hybridization, therefore no change in hybridization of any atom. That is the result of this problem.